So hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here at AWS. Again this week we are joined by Nick Ihli in Utah from SchedMD. Hey Nick.
Hi, thanks for inviting me again.
And Austin Cherian, based out of Singapore in our developer advocacy engineering team here in HPC. So you guys are going to pick up the conversation that we started earlier in the week with the migration from SGE to Slurm. And I guess what's the topic we're diving in today, guys?
So today we're going to be looking at job scripts, basically. Our last tech short was around top-level commands and looking at job submission. But, here we're now going to look at the actual script, right? What are the differences? Going to compare and contrast a couple of things. And, Nick's going to do, all the magic with respect to showing it on Slurm. So let me just start with, quickly showing what an SGE job script would look like. And this is something that you might be familiar with, right? So right over here, Brandon, if you show the graphic, I'm just going to quickly circle, what a single node job submission looks like. In this case, we're looking at a SchedMD job with, essentially eight threads. And the idea is that it's a single node, right? And on the right-hand side, this is something that you might be familiar with when you start scaling your application. This is an SGE script that is essentially 8 nodes with 28 cores each, right? And the idea over here is, to get you familiar with what this looks like probably on your side. And now Nick's going to take us into what these would look like on the Slurm side, essentially. So Nick, maybe you can take it away in terms of giving us a walkthrough of that.
Yeah, great. So let's switch over to the demo terminal.
Cool.
And what I'm going to go ahead and show you is just a sample script that's very similar to what we just saw that Austin showed us, but with the S-batch options in there. So the main thing to understand, we've been talking about the commands previously. The next thing is, okay, how do we make my job scripts work like work for Slurm that we were using with SGE. So the main thing you're going to do is you're going to change your pound $sign into this pound S batch. That's your main signifier of requirement requests. So here I'm requesting an account. That's can be like a project. There's a couple different things you can do there. But mainly we have different accounts that you can set up in Slurm, and we'll talk about those in a later tech short of how you create these, how you create the accounts and what they're set up for. And one of the things that's kind of most questions are about is my specific requirements of memory, nodes, CPUs, etc. Here I'm just requesting a specific partition. Now, if you remember from last session, we had one partition compute. So I wouldn't technically need to put this in there because that's the only partition that we have and it would be there by default, but just wanted to show that. So that's where I want to maybe send it to a very specific set of nodes or groupings of nodes. And then I am doing a dash lowercase n for the number of tasks that I'm going to be requesting. And in this case, I'm requesting 8. And by default, each task is 1 CPU. You can add more to that to determine how many CPUs each task is going to be. And of course, you can build this out further. So there is more that you have to do. But from a kind of a first pass standpoint, we're just going to be talking about more of a simple job, and this is where we would be able to help you and work with our customers to build this out further. And then cap n is going to be the number of nodes. I also put up here commented out fully of just other options. So most of Slurm's S-batch options, they support kind of the dash one single letter, but also they support the dash dash, more of a larger word here. So this dash lowercase n can also be dash dash n tasks, and this dash uppercase n can also be dash dash nodes. And in this case, if we use these, it would be, let me just add this right here. It would be, and n tasks equals and dash dash nodes equals, where we see with the dash n, we just do a space 8, or it also supports just doing dash n8 like that. So we kind of give you an idea on that.
This works out for great readability when you're actually exchanging scripts, essentially, rather than getting confused.
Correct.
And Nick, you need to always specify the minus uppercase n. Like if it's 8 cores and you've got the natural node size on your cluster is 36 cores, for argument's sake, is that even necessary to specify?
Yeah, no, that's a good point. You wouldn't necessarily even need that. If I'm just doing dash lowercase n8, I just want 8 tasks, and that could be a thing where I'm saying this with Slurm. When I say I want a node, you get a node. One node. So you may want this if you want to make sure that the job is staying on a single node. If you don't care how it gets split up, then you could just do the 8 tasks and get rid of the cap n, and you could maybe have 4 on one node and 4 on another node potentially. But the one great thing about Slurm is when you ask a node, what you ask for is what you get. So you want a node, you'll get for sure one node. You want 2 nodes, you'll get 2 nodes.
Makes a lot of sense. So you've got room to have an opinion about how you want your job laid out, but you don't have to be too opinionated if you don't. Yep, cool.
Absolutely.
And so here we see the job name information, so dash dash job dash name or dash cap j, time limit, so s batch dash t for the time limit, and that can be in multiple different formats, or dash dash time equals. And then we have our job details like you normally would have, and then you have a job that's ready to go. So let's go submit this real quick. So we're going to do s batch demo underscore job. The job's running. We can see that it is running on a static node that we have that's large. Let's look at more information about the job here. Show s-control show job 279. And we see that it's using 8 CPUs because we requested 8. It's using that department A account that we requested. The job name is test job. And we can see that the time limit there is 5 minutes.
Awesome. Great. I think the other aspect I would just highlight over here is that if you did not specify the number of nodes and you're not aware of what's happening, then there's a good chance that your job is getting split, right? And so there are performance aspects that might come in. Just want to just talk about that a little bit. Yeah, that's great, Nick. Could you also give us an idea of how to run a multi-node job submission?
Yeah, so let's talk about that. As you saw in the example that you showed, a little bit more comes into play when you're doing an MPI job. So let's go over to a different user that I have set up here, demo 1 user, and I'm going to go to a different directory. And here I have a job, an MPI job. And you're going to see a couple different options. So let's look at these. So one, let's go back to the request of how many nodes and resources that I want. Here I'm doing the dash n2. I want 2 nodes. Commented out, I have one that wants 4, and I'll show that in a little bit. And here I've translated what was being requested from the SGE side to 2 tasks per node. So I want 2 nodes. I'm going to get 2 tasks per node. So that's going to basically put 2 CPUs in use on one node and 2 CPUs in use on another node. There's a couple of different ways that when you start looking at the Slurm documentation, you can see how you could translate the SGE need to requirement to Slurm. And this is the one that I've chosen in this case. And then we see, all the other information is the same. Now, one difference here is in the MPI run. In the MPI run, I'm not doing the dash NP. Okay, the dash NP is not required because MPI run is actually able to automatically pick that up from Slurm. So that's nice. You don't need to put that in there. You don't need to with dash NP, figure out how many CPUs are being used, etc. That will get automatically picked up.
Great. I just one question over here though, Nick, is that in case users actually go ahead and put the dash NP over there, which one gets picked up basically?
Yeah, so if you explicitly put it in a -np and you, let's say for some reason you did less processors that are being used than what it would have picked up automatically, it's going to use what the -np is.
Perfect.
But that is one nice thing that you can take that out and don't need that. And then there is this other option, another submission command in Slurm. It's called srun. That doesn't necessarily queue up a job, but you can run sruns inside of an sbatch script. And with MPI workload, if your MPI is configured to work with Slurm and set up in the proper way, you can do sruns inside the sbatch script for you instead of MPI run. And that enables you to just have a little bit better tracking. But that's a little bit more an advanced topic, but I just wanted to share that because as you get more versed in Slurm, there's some optimizations that you can make to these job scripts.
Oh, sounds great. And I think now I'd like to just switch topics a little bit to the environment variables. So Brendan, if you could just bring that graphic up again.
There you go.
Right. So, essentially we've been talking about job scripts for now, but, environment variables can be really, really powerful in terms of controlling your job scripts and, putting in tags and things like that. So for users out there who are looking at this, this is probably what you've been looking at in terms of SGE environment variables. And obviously there's an equivalent set of this on the Slurm side. And probably, Nick, you can just talk to that now. And I guess it's below there.
And is that this? That's this table down here, right? Do I zoom in on that?
Yeah. So this is a really good table, and there's a lot of great resources out there on the web for comparisons like this. But as you see, very, very similar. Job ID is just Slurm_job ID. Most of the Slurm variables you'll see have that Slurm option before it. So it's very, very easy to kind of take what you had been doing and move that over. There's just a few extra words here and there. You look at your PE host list. You have Slurm_job node list. And slots is that end task that I showed. Or Q, as we talk about partitions, is Slurm job partition. So very, very similar. If we can show the terminal again, what I'll do is I'll give you a list of basically every variable that's kind of out there. And I can kind of quickly show you that. So let's actually submit a job that is going to output just all of the all the variables. So we'll go ahead and do that job. It's going to run extremely fast. So I'll go ahead and cat this file now.
Sure.
And here we see all the different Slurm variables. So a lot of them that are available that you can take a look at and use for your job scripts.
It's quite useful, though. I mean, essentially, you just go and have a reference of these, right? Essentially.
Correct. Yeah.
And I guess you have a couple of other aspects around wrapper scripts. Do you want to go through that?
Yeah, there's kind of two areas I want to talk to. As we were talking about in the commands, we have those wrapper scripts that help ease in that transition. Well, we also have a wrapper script for QSub. And that makes your job submissions very easily. This was originally developed for kind of PBS systems, but then again, in a project we did with a customer, we added in SGE capability. So if I just run QSub, you'll see the different options that you have. And one thing that you can do is add an option called --sbatch line. And what this is going to do is actually not going to run the command and submit a job, but it's going to show you what the sbatch options would look like. So here's a very common method for SGE QSub submission using the -PE. So we're going to go ahead and run that. And what this will show me is what that sbatch line looks like. So it's going to add in the for our output and error file. It's going to look like this. It's going to secondly, it's translating the -PE to the CPUs per task.
Right.
Another option we could look at is, let's look at a time limit request. Okay, so we did the -LH_RT = 600 for our time limit, and we see when that outputs to sbatch is a -T10. So we're able to, you can run these different commands and start getting a kind of a better understanding of what would that translation be to the Slurm sbatch command. But also, really let's go and submit a job.
Sure.
So I'm going to use QSub doing the -PE SHM8 in a test job. In this case, I get my job ID back there, 281, like I would when I'm running QSub in SGE. And I can do my QStat again, as we showed before, and we see the job running. So let's do the Slurm command, the SQ, and we see it there. So that allows us to.
That's really cool.
You are going to save everybody the effort of even having to learn anything new, and it's going to come back to bite them at some point.
It's probably going to stick with this, right? Exactly.
This is really cool.
But this is amazing. I really like the aspect of it giving out the recommendation on the Slurm command, which is pretty cool, and you can start learning from that as well, basically.
Yeah.
Yep.
And then connected to this too, we do have, there's a couple options in Slurm, a submit filter that you can actually write a C or a Lewis script that when a job is submitted with SBatch, a job submitted, you can catch what's being submitted, make changes to it, add to that submission to kind of direct the job the way that you want to do it, or where the user doesn't have to have as much knowledge about the system. So that's something that we also recommend sites as they're migrating over. Take a look at the submit filter, and you from an administrative perspective can make life easier for users by putting their jobs through filters and helping them out a little bit. So that's something to take a look at as well.
Yep, essentially auto-applying job requirements and things like that.
Correct. Mm-hmm.
Basically. Very nice. Well, I think that's about wraps it up for us for this section, and we'll have another section covering more advanced topics like job queries. Well, thanks, Nick, for joining us.
Yeah, that is super. That is really super cool. I love all of that stuff. Like I say, you guys have actually you're potentially making it too habit forming for people to not move, but you've definitely saved everyone's bacon. So we're going to come back for the next tech short that we're going to do in this series. Thanks, guys. Talk to you soon.
Thank you.
Thank you.